Kowloon to Canton Railway Corporation operates a passenger service from Kowloon to Lo Wu on the Chinese border. Traffic on this system totals 60 million tonnes per line annually, and recently, when it was recognised that the track support was losing its resilience with the ballast approaching the end of its useful life, tenders were called from the United Kingdom, Europe and Australia to carry out total ballast replacement of the mainline track. The task is not an easy one, as the railway operates for 20 hours each day. All work on the line must be done in the brief non-service period of 0130 to 0500 hours, and still allow trains to run immediately afterwards. Barclay Molam was successful in gaining the contract, the decision having been made not only on price, but also on the method of working they proposed. The Barclay Molam reballasting process is a highly mechanised method of single-line working, and in building up an efficient ballast handling system tailored to the client's needs, Barclay Molam mobilised plant and resources from around the world. The modified Plaser & Thura RM74 reballasting machine came from Germany, with other plant items drawn from Australia, the USA and China. The conveyor units handling old and new ballast were designed by the Barclay Molam Resource Engineering Group and were manufactured in Hong Kong. Prior to the start of each shift, the 400-metre-long reballasting train is hauled from the project base to the work location by 2 KCRC locomotives. The cutter bar and excavating chain are generally left in the track during the day and reconnected at the start of the shift. This operation taking about 10 to 15 minutes. To prepare for reballasting, the offloading conveyor is positioned, the conveyors are started on all dirt and ballast wagons, and the noise barriers are put into place. Once set in motion, ballast replacement flows along as a continuous process. In one pass, old dirt ballast is removed and new ballast is placed below the sleepers without removal of the track. The RM74 excavating chain extracts the old dirt ballast and moves it onto the material conveyor system at the front of the machine. Normally 10 to 12 conveyor units are used, each fitted with an adjustable tilt conveyor truss for working on various track cants. Once the old ballast has reached a predetermined height inside the storage area, the plough is moved forward for even distribution of the load. Incoming new ballast is fed in from 8 wagons, each having from 4 to 9 hopper compartments. Conveyor units underneath transport the ballast to the reballasting machine. The conveyor truss is also being adjustable for work on variable canted track. New ballast is fed onto the conveyor system by opening specially designed clamshell doors, the opening being cued by lamp signalling. A light on means that ballast is needed. Specially modified for this project, the RM74 has an additional new ballast intake conveyor constructed over the rear cabin to feed into the hopper previously used for ballast cleaning. The RM74 hopper operator regulates the amount of incoming ballast by lamp signals, and also controls the flow of ballast onto the offloading arms via sluice gates. New ballast is distributed by a purpose-built plough, which allows the passage of the wagons behind. There is only a 4-metre gap between the excavation point and the area of new ballast placement, thus providing security of service even in the event of an unforeseen breakdown. Cutting generally takes place for 2 hours, during which time the train may replace 600 to 800 tonnes of ballast. But output can average 200 to 250 metres per night in good conditions, with a record of 283 metres achieved. Following reballasting, the chain and cutter bar are disconnected and left in the track for commencement of the next shift, the cutting out typically taking 15 or 20 minutes. The 4-metre section without ballast is filled with ballast, with shovel packing of the last 10 metres if needed to minimise track settlements. The train is moved off the site by 2 locomotives at a steady pace, whilst the required quantity of additional ballast is dumped on the shoulders. Concurrently with the cutting work, the reinstatement crew carry out their tasks on the previous night's reballasting, as well as first lift reinstatement on the newly reballasted track. A survey team sets out and monitors all stages of the work to ensure reinstatement of the track to the desired line and level. All reballasted track being maintained to horizontal and vertical alignment for up to 5 days from reballasting. Mechanical tamping is carried out by 2 Mark III tampers, which lift and align the track whilst compacting the new ballast under the sleepers. Each machine has specially designed output shaft workheads to tamp guardrail areas and inclinometers to help achieve the tight tolerances required by the KCRC. Following the tamping, the Type 62N dynamic track stabilizer takes over. A combination of powerful horizontal vibration and vertical loads gives a homogeneous structure to the ballast bed and promotes higher vertical and lateral stability, hence enabling high operating speeds on the reballasted line. The regulator used to equalize the track ballast before and after tamping also brooms ballast from the top of the sleepers and profiles the ballast shoulder to the client's specifications. Speed restrictions on the reballasted track cover 3 work shifts, with the track back to full line speed after day 3 of the reinstatement works. Following each night's work, the reballasting train and the reinstatement machines return to the project base near Lo Wu for maintenance and for ballast handling. New granite ballast from a local quarry is loaded using a front-end loader, while old dirt ballast is dumped in a separate area of the yard for later disposal. A detailed preventative and corrective maintenance program is rigorously followed each day, and competent, experienced personnel are able to keep up the high standard of reliability and performance required of the machines. In addition, innovative modifications are made to the RM74 machine on a continuing basis to permit reballasting through platform and tunnel areas, and in circumstances of very restricted clearance associated with bridges, drains, service pits and the like. The project is unique because of the very limited track possession available for total reballasting of such an intensively used railway. And Barclay Molen's commitment to innovation, plant reliability and close cooperation with the client has been the vital factor in successfully working with the Kowloon to Canton Railway Corporation.